Good afternoon, Sauhegan, and if you watched our last video, 812C, I said that I would be talking about the remainder theorem and the implications that it had. So I've already set up our problem. We're going to do polynomial P as our, and then divided by our quotient, Q, and I've got our box all set up, ready to go. We always start with that first term going in the box. What do we multiply x by to get x cubed? That's x squared. Fill in the box down below. Now what am I going to add? 0x squared. What am I going to multiply x by to get 0x squared? 0x. Continuing on, we have 0x times negative 2. What am I going to add to 0 to get 5x? We're going to add 5x. And then we fill in our last x times 5 is 5x. And when we look down here, we have negative 10, but we want negative 8. We want negative 2, but we have negative 10. That means our remainder is positive 8. So what I want to do now is show you what that positive 8 represents. So graphically, if we were to look at that, we can see here that if I look at the point 2, 8, that remainder 8 represents the y value. So this is the y value when x minus 2 is 0, when x is 2. So when x is 2, our y value is 8, and it represents the point 2, 8. Another way that we could look at that is we could actually take 2 and plug it into our function. So we're evaluating our function when x is 2. So let's just see what we get here. And lo and behold, we find out that p of 2 is 8, which again, if we look at our graph, that represents the point on the graph when x is 2 and y is 8. So basically what the remainder theorem says is that if you have a quotient x minus c, that when you plug c into a polynomial, it will end up being whatever your remainder is. The next video that we will look at what happens when that remainder is 0. As always, we hope you remain safe, healthy, and happy. Please make sure you're taking care of yourselves and the ones you love, and that you're practicing safe social distancing. Miss you and love you. Bye.